Good morning everyone. So in the previous slide we have been discussed about what do you mean by storage headwork, diversion headwork, how to select the site for the diversion headwork and what are the components of the diversion headwork. Okay. So in the components of the diversion headwork we have discussed about the different components, that is wearer barrage, under sluices, divide wall, test ladder, canal head regulator, silt excluder and silt prevention devices and river turning work. So wearer barrage we have been discussed, under sluices also discussed, divide wall, freeze ladder, canal head regulator we have also been discussed. So today we will be discussing about, that is silt excluders and river turning work. Okay. So here we will discuss about silt regulation work. The entry of silt into the canal which takes off from a headwork can be reduced by constructed certain special work called as silt control work. There are two types, that is silt excluders and silt ejectors. In the silt excluders are those works which are constructed on the bed of the river upstream of the head regulator. The clearer water enters the head regulator and silted water enters the silt excluder. In this type of work, the silt is therefore removed from the water before it enters to the canal. Next, in the silt ejectors are also called as silt extractors. These are those devices which extract the silt from the canal water after the silted water has travelled a certain distance in the off-taking canal. These works are therefore constructed on the bed of the canal and the little distance downstream from the head regulator. Okay. So in the silt regulation work we have discussed about the silt excluders and silt ejectors. Okay. In the silt excluders, these are the structure which have been constructed on the bed of the river upstream of the head regulator, and in the silt ejector, these are the silt extractors. These are those structures which extract the silt from the canal water after the silted water has travelled a certain distance. Next, the last component we will be reading about, that is the river training work. The river training work are required near the weir site in order to ensure a smooth and axial flow of water and thus to prevent the river from outflanking the work due to a change in its course. So in the river training work it requires on a canal headwork, that is guide banks, marginal bonds. Next one is spurs or gravenis. In the guide banks, when a barrage is constructed across a river which flows through the alluvial soil, the guide banks must be constructed on both the approaches to protect the structure from the erosion. Guide bank serves the following purposes. It protects the barrage from the effect of scoring and erosion. It provides a straight approach towards the barrage. It controls the tendency of changing the course of a river. It controls the velocity of the flow near the structure. Next is marginal bonds. The marginal bonds are earthen embankments which are constructed parallel to the river bank on one or both the banks according to the condition. The top width is generally 3 to 4 meter. The side slope on the river side is generally 1.5:1 and that on the countryside, that is 2:1. The marginal bond serves the following purposes. First is it prevents the flood water or storage water from entering the surrounding area, which may be submerged or may be waterlogged. It retains the flood water or the storage water within the specified section. It protects the towns and villages from devastation during the heavy flood. It protects the valuable agricultural land. So, in the river training work are mainly required near the weir or barrage site to ensure a smooth and axial flow of water. Okay. So, these are the three river training work that we require, that is guide bank, marginal bonds and spurs or gravenis. So, guide banks means when the barrage is constructed across a river which flows through the soil, the guide bank must be constructed. Okay. Next is the marginal bonds. These are the earthen embankments which are constructed parallel to the river bank on one or both the banks. and the slope of the marginal bonds, that is 1.5:1, and in the countryside, that is 2:1, and the top width of the marginal bond is about 3 to 4 meter. Next, we will be reading about what are the causes of failure of the structure. Okay, how you have been reading in the newspaper or listening the news that the dam has been failed, that the structure has been damaged due to some reasons. Okay, so how or why the causes of failure of the structures? Irrigation structures or hydraulic structures for the diversion and distribution work are weirs, barrages, head regulators, distributary head regulators, cross regulators, cross drainage work, etc. These structures are generally founded on the alluvial soils, which are highly pervious. These soils are easily scored when the high velocity water passes of the structures. The failures of the weirs constructed on the permeable foundation may occur due to various causes, which may be broadly classified into following categories. First one, that is failure due to subsurface flow, and second one, that is failure due to surface flow. Okay, so in the failure due to subsurface flow, first is that is failure by piping or undermining. Second one, that is failure by direct uplift. So in the failure by piping or undermining, water from the upstream side continuously percolates through the bottom of the foundation and emerges at the downstream end of the weir or barrage floor. The force of the percolating water removes the soil particles by scoring at the point of emergence. As the process of removal of soil particles goes on continuously, a depression is formed which extends backwards towards the upstream through the bottom of the foundation. A hollow pipe-like formation thus develops under the foundation, due to which the weir or barrage may fail by subsiding. This phenomena is known as failure by piping or undermining. Next, that is a hollow pipe-like formation thus develops under the foundation, due to which the weir or barrage may fail by subsiding. The phenomena is known as, that is failure by piping or undermining. Next one, that is failure by direct uplift. The percolating water exerts an upward pressure on the foundation of the weir or barrage. If this uplift pressure is not counterbalanced by the self weight of the structure, then it may fail by rupture. Okay, so in the failure by direct uplift, the percolating water exerts an upward pressure on the foundation of the weir or barrage. If this uplift pressure is not counterbalanced by the self weight of the structure, then it may fail. Next, that is about failure due to surface flow. Bit 1, that is by hydraulic jump. Bit B, that is by scoring. Okay, so by hydraulic jump, when the water flows with a very high velocity over the crest of the weir or over the gates of the barrage, then the hydraulic jump develops. This hydraulic jump causes a suction pressure or negative pressure on the downstream side, which acts in the direction of uplift pressure. If the thickness of impervious fluid is sufficient, then the structure fails by the rupture. Okay. Next, that is by scoring. During the floods, the gates of the barrage are kept open and the water flows within the high velocity. The water may also flow with a very high velocity over the crest of the weir. Both the cases can result in scoring effect of the downstream and the upstream due to the side of the structure. Due to the scoring of the soil on both the sides of the structure, its stability gets endangered by shearing. So, in the failure due to surface flow, bit 1 by hydraulic jump and bit B, that is by scoring. In the hydraulic jump, when the water flows with a very high velocity over the crest of the weir, then the hydraulic jump develops. And in the scoring, during the floods, the gates of the barrages are kept open, so the water flows with a high velocity. Okay, both the cases can result in scoring effect on the downstream and the upstream side of the structure. Due to the scoring of the soil on both the sides of the structure, its stability gets endangered by shearing. So this is all about the causes of failure of the structure. So that is first, that is failure due to subsurface flow and failure due to surface flow. So this is all about this. So thank you. So we will be starting the next chapter in the next slide. Thank you.